Class 6, Science, Chapter 12, Electricity and Circuits. Animated Science, Introduction. Electricity. Electricity is the flow of electric current. We use electricity to light up our homes, power our microwaves, fridges, washing machines, TV, video games, etc. A power station provides us with electricity. However, sometimes when the supply of electricity may fail or it may not be available in some places, a torch may be used for providing light. Let's learn about the inside of a torch, electric circuits and conductors and insulators in detail. Electric torch. As we already know, a torch provides us light when there is no electricity. The inside of the torch has the following parts: bulb, which lights up when the torch is switched on; electric cells, which produce electricity; switch. When the switch is turned on, electric current flows and the bulb glows. A switch breaks or completes the circuit. Electric cell. The electric cell is a device that produces electricity. The electric cell provides electricity to the devices like torches, alarm clocks, wristwatches, transistor radios, cameras, video games, etc. The torch cell has two terminals, that is, a positive terminal and a negative terminal. It has a small metal cap on one end and a metal disc on the other end. There is a plus sign marked on the metal cap end of the cell and a minus sign marked on the metal disc side of the cell. Therefore, the metal cap is the positive terminal of the electric cell and the metal disc is the negative terminal of the electric cell. The chemical stored in the electric cell produces electricity. When this chemical is used up, the electric cell stops producing electricity and it has to be replaced by a new one. Electric bulb. A torch bulb has three main parts: metal base that conducts electricity, outer case of glass that surrounds and protects the filament, thin wire called a filament. The filament is connected to the terminals of the bulb. The filament gives light when the torch is switched on. The filament in the bulb is fixed to two thicker wires which provides support to it. One of the thick wires is connected to the metal case at the base of the bulb. The other thick wire is connected to the metal tip at the center of the base. The metal case and the metal tip are the two terminals of the bulb. Sometimes an electric bulb does not glow even if it is connected to the cell. This may happen if the filament of the bulb is broken. Such a bulb whose filament is broken is called a fused bulb. The break in the filament of an electric bulb means a break in the circuit. Therefore, the fused bulb does not light up as current does not pass through it. Electric circuit. For the torch to work and the torch bulb to glow, the path of electricity from the cell to the wires and from the wires to the bulb should be complete. If this path is broken or incomplete, the torch will not work. An electric circuit is complete, unbroken path through which electric current can flow. An electric circuit is a closed conducting path. In an electric circuit, the current always flows from the positive terminal to the negative terminal. If there is a gap in the circuit, then no current will flow as the circuit is incomplete. An electric circuit consists of bulb, cell, conducting wires. These wires are made up of a conducting metal, usually copper. The copper wires have a plastic covering over them so that we don't get a shock when we touch them. For example, consider these four circuits. Which circuit do you think will work? Circuit B will work as the circuit is complete. The circuits A, C and D will not work because the circuit is not complete. Electric switch. A simple and easier switch can be made in the following way to use in a circuit. A switch can be made using two drawing pins, a safety pin or a paper clip, two wires and a small sheet of thermocol. Put a safety pin into drawing pin such that the ring at the end of the safety pin goes in the drawing pin. Now fix it on the thermocol sheet, as shown in the figure. Make sure that the safety pin can be rotated freely. Fix another drawing pin on the thermocol sheet at a proper distance such that the free end of the safety pin touches it. The safety pin will act as a switch. Now, take two wires and make a circuit by connecting electric cell and bulb with this switch. The safety pin should rotate so that its free end can touch the other drawing pin. In this position, the circuit is complete and the bulb will glow. Now, if the safety pin is moved away as shown here, the bulb will not glow. The safety pin covers the gap when it touches both pins. This position is the on position. Since the safety pin is a conductor, it allows the current to pass through it. Hence, the bulb glows. The bulb does not glow when the safety pin does not touch the other drawing pin. The circuit is incomplete as there is a gap between the two drawing pins. This position is the off position. A switch is a simple device that either breaks the circuit or completes it. The switches used in lighting of electric bulbs and other devices in homes work on the same principle, but their designs are different. Conductors and insulators. Electrical conductors. Electrical conductors allow electricity to pass through them. They conduct electricity. Metals like copper, steel, aluminium, graphite, etc. are good conductors of electricity. Electrical insulators. Electrical insulators do not allow electricity to pass through them. They do not conduct electricity. Wood, rubber, plastic, glass, etc. are electrical insulators. For example, consider circuit A and circuit B. Circuit A has a key attached to it. The key is made of metal, hence it conducts electricity, which means current flows through circuit A. Circuit B has a rubber band attached to it. The rubber is a bad conductor of electricity, that is, it is an insulator, hence it will not conduct electricity, which means current does not flow through circuit B.